Hey, what's up, guys? It's Jack.Lion here again today, and I'm gonna bring you guys this cool max4live patch. This is actually a jit.gl.pix video, but I have this embedded into a Max device, which you can pick up from the Patreon if you're a patron. Or otherwise, feel free to follow along with this video. And I guess I could start by showing you how it works. So essentially what we're going to do is take MIDI as an input, but all that MIDI does is get converted into an integer, which selects a part of the screen. So let me show you what I mean when I start playing this. Okay, so you can ignore all the special effects. What you noticed probably was that box that was happening, and what that box represents are MIDI notes. So the MIDI notes of the scale degrees can be flashed across the screen, essentially an audio reactive kind of style. And that's an effect that I think is pretty cool. So we're going to explore that and how to do it. Um, so I guess we'll start with the basics. Okay, so to start off our patch, we can just grab a max MIDI effect. And we can open it to get started. So here is our default max MIDI effect. Okay, as you can see, we have our MIDI in and MIDI out. We want to keep that, but keep it out of the way. So I usually will just patch that up and call it MIDI pass. Okay, cool. Now, next, what we're going to want to do is start by creating a jit.gl texture to drive the process behind jit.gl.pix, which we can create now. And connect those like so. And rather than creating a jit world object, we can create a jit p world. And that'll enable us to just render with this window without setting up the whole render context itself. And all we need to do is route a bang out of that and then loop it. Okay, so we're going to get a blank texture because right now there's really nothing going on inside of our jit.gl.pix. Okay, so here's the trick. What we want to do is delete all these. We're going to start with norm. Okay. And then what norm's going to do is give us the screen space coordinates from 0 to 1. And what we're going to want to do is have that multiplied by a parameter that selects the number of screens. So we're going to create that now by declaring a param, calling it screens, and giving it a default value. All right. Now, the next thing we want to do is create a fract object, connect that, swizz the X component. Okay, and then we'll leave that for now. And from here, we're going to branch out and typecast to an int. And then we'll use this comparator so that we can compare that integer to another parameter input, which will be the selection of the screen space. So we'll give it a default of 1 and just plug that in here. So what this is going to do is compare this to this, essentially. And it's going to say if the screen space that we're selecting, that we're determining, matches this value, this integer, then highlight that section. So how do we tell it to highlight that section? We use a ternary operator. This is a conditional, and what we're going to do is plug in this component here and that component there. Actually, rather this here, because whether this is true or false will tell it to take in this other input, essentially. So what this other input is for now is just going to be white. So when we visualize that here, this is what it looks like. Okay, so what are we seeing? So from here we can see if we change our parameter for selection, then we highlight a different section of the screen. So let's take a moment to analyze this a little more closely, right? So we're taking the screen space coordinates, multiplying them by whatever we want. This is the number of screens that we want, the number of divisions, right? And we're taking the fractional component of that. And when we take just the X, this is what we get, right? So basically what we're seeing is this 0 to 1 kind of wrapping around 7 times, right? So when we want to compare it to our selection, it highlights that specific part of the screen. So we can tell it what we want to highlight based off of these two inputs. So let's say, instead of just black and white stripes, we have an image. And then instead of a white bar, well, just to demonstrate first, we can make it any color we want. We can make it black, we can make it red. But what we're really interested in is splitting a sort of like texture input into 2 paths, and then using one input as like the base, and then the second input as like a glitchy layer or some kind of like processed version. Or you could use a second video input if you want. So I'll show you how to do that. Okay, so first let's actually go back to our patch, and we want to create an attribute for the screens and for the selection. Okay, so that way we can actually tell dynamically how many we want. If we want no selection, we can go into a negative number. So screens, let's divide it by 3 screens or 4 or 40. We can do that. I try to keep it smaller just so that, it's a little bit more easy to perceive, a little bit more easy to digest. So what we're going to do is do some fancy stuff in the selection area. Okay, so let's dive right into that. First, open back up jit.gl.pix, and we're going to want to create 2 inputs, and I'm just going to call them input 2 and input 3, just so we don't get confused with the first input, which is just our dummy texture. And then what do I want to do? What I do want to do actually is replace this, and then also replace that. So that means that we no longer need these objects. Those are just to visualize the screen space division. And our setup looks something like this. All right, so let's just grab 2 simple video inputs. So maybe this one and this one. All right, so I'm going to allow these to loop and send them in. And now we can see our selection consists of the dishes. And we can change that part of the screen. We can go to 0, go to 6, which doesn't exist, so we go to 4. So yeah, as you can see, like, we have a very versatile system to work with now. Okay, so the next part of the video, I'll show you what I like to do with it, which is use jit.gl ISF, which is a package you can get from the package manager. Pull that up real quick. So we'll go to ISF. So you'll have to get this installed. I believe there's a few extra steps to use the shaders that they have with ISF. That's a little bit beyond the scope of this video, but I already have mine installed, so I'm going to go ahead and use ISF. So let me just get rid of these. If you want to, you can actually use jit.movie. I like to say output texture 1. and then volume 0. And then we can just grab a read attribute. We're just created ourselves with a message. So read, start, and stop. This is our basic setup for grabbing movies from our disk. And then, of course, we just copy and paste that. But I'm not interested in 2 videos anymore. So what I'm going to show you now requires jit.gl.pix. I already have mine set up, so I'm going to skip to the part where I'm just demonstrating. All right, so I have this patch up. It's based off of the patch that I showed you how to make, and this is with jit.gl.pix set up. So what happens is we can apply like whatever kind of effect we want to our selection. So if I select, and then this is a part of the video I'll show you at the end. So let's keep that amplitude 0 for now. So yeah, I can like basically affect whatever's happening in that selection space, right? So like, let me make it smaller, like 4, and give it selection 2. Right, so you can imagine if MIDI is like bouncing this thing around, then we can get all kinds of cool variations, especially if we control the parameters while it's moving. So this is how I like to use this effect. This is what I tend to use it for, is applying different kinds of cool looks. We have in here a lot of different effects that you can choose from, as well as the shaders included in Max itself. Here, I want to show off this one. Yeah, this is a cool one. So yeah, there's plenty of effects to choose from. You kind of can get creative with it, you know, using this as a launch point. I'll show you one more trick, which is how to basically distort the edges, right? So we can give it a sort of sinusoidal look that kind of bounces around instead of just like a plain box. So I'll show you that now. Okay, so what we're going to want to do in order to apply different kinds of distortions to the actual edge is we're going to want to operate on this output right here. So let me move some things down, make some space. And then what we're going to do here is swizz X and then swizz Y. Right, so then we're going to want to also swizz the Y from the norm. And then I can go ahead and cut this here, because what we're going to do is connect what we're going to compose back into there. So what I want to do from here is multiply times frequency. Now we don't have a parameter called frequency yet, so I'll create it. And we'll give it 100 as a default. Go ahead and connect that. And then we're going to plug that into a sine. And then from sine comes amplitude. And then what we're going to do is create that as well. Call it amp. And give it 0.1. All right, and then what we want to do from here is add this to the X component. So we're going to add that distortion to the X, and then what we want to do from here is recompose that into a vector. So we can do that with the vec object and giving it an argument of 0, 0. And we plug the X into here and the Y back in here. And then voila, we should have some nice curves, right? So what we can do is add an attribute. Now that we've created the parameter, where is it? Amplitude, so that's amp. And frequency. So now you can apply these kinds of distortions as well. Oh, and I almost forgot. There's one more thing that we need, in order to get MIDI to play kind of nice with this. And it's a little bit of a hack that I have going on now that I'm still working on, but I figure I can show you in the meantime. So what I'm going to do here is just create an outlet to get started, because I want to connect this to an integer, and that integer can get plugged into the selection. All right. Sorry. So there's an outlet in here. That's what we're going to use to start with. And I'm going to start from the top and go, we're going to need a note in. Okay, and then I just want to connect that to ddg.mono just to keep it monophonic. We'll plug these in like so. All right, and then what we're going to want to do is take the modulo of 12. And the reason being that we want to wrap around an octave. An octave consists of 12 notes. Therefore, we want a modulo of 12. And we're going to send the velocity just to keep the patch a little tidy. All right, and then what we're going to want to do is grab a zl.lookup. All right, and then I'm going to create another subpatch here and call it listinit. And what we're going to do in here is create a load bang, followed by an Uzi13, then followed by a counter, and then zl.stream with an argument of 13. And that's going to go to an outlet. So we can plug that outlet into the right input of ZL lookup, and then take the modulo out and plug that into the left inlet. Okay, and then I'm going to go ahead and trigger this. What this is a list that comprises of 0 to 12, I believe. 0 to 12, and that's just going to tell ZL lookup that we're looking at these integers that represent our scale degrees or our semitones. So what we're going to want to do now is route to actually take out the notes that we don't want. And this requires a little bit of knowledge into music theory, and you don't even have to do this step if you don't really care. But what happens is, because scales consist of half steps and whole steps, some of those whole steps are going to create gaps in the screen space selection. So in an attempt to try and mitigate that, we're going to use routing objects. So I have a configuration for C minor, and I'm just going to paste that in here. So if you want to think about it, just consider 0 as your root note, and then 1 would be like the first degree, or like a half step away. So each integer represents a half step, and you just sort of have to think about the scale that you want, right? So like I said, this isn't a completely necessary step, but I think that it makes things look a little bit nicer. So I'm going to send that into a trigger bang float and then receive the velocity down here. And then what we want is a conditional statement that says if input is equal to 0, then -1, else we're going to want the second input. Now the reason we're doing that is because -1 will basically say, like, okay, if there's no note being pressed, aka 0 velocity, then there's no, what do we say? There's no selection to be made, and a negative number will make sure of that. So last thing we need is a scale to go from 0 to 11, which is 12 semitones, to about 7, 0 to 6, 7 scale degrees, essentially. So this bang gets sent into here, so that every time this gets updated, this gets banged, and that should be it. Now whenever we play MIDI, And there you have it. All right, I think that'll be it for this video. I'll leave the patches available for patrons. If you like the video, please consider subscribing. I hope the video was helpful to you, or at least interesting. I'm going to get going, and it's been nice seeing you. Later.